Good day, young whippersnappers. Last time with Coach Goo, we did the Pythagorean theorem. This time we're doing the converse of the Pythagorean theorem. Let's read this thing together, shall we? The converse of the Pythagorean theorem. If the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. That pretty much means if c squared equals a squared plus b squared, then the triangle is a right triangle. Now take a second and digest that. But now let's take a look at two other cases. Pow! All right, so there it is. Now look, if the square of the length of the longest side of a triangle is less than the sum of the squares of the lengths of the other two sides, then the triangle is an acute triangle. So that says if c squared is less than a squared plus b squared, then it's going to be an acute triangle, a cute little triangle. And if the square of the length of the longest side of a triangle is more than the sum of the squares of the lengths of the other two, there's so many ofs in the sentence, then the triangle is an obtuse triangle. So if c squared is greater than a squared plus b squared, then it's going to be an obtuse triangle. So let's take a look at some examples of how we would use this converse. Right here, prove the figure below is a right triangle. Remember, if it's going to be a right triangle, then c squared equals a squared plus b squared. So let's substitute things in. C squared equals a squared plus b squared. Okay, c is definitely going to have to be here because it's a hypotenuse. A and b doesn't really matter which one of the legs we choose as long as it's a leg. Now let's substitute things in. So 39 squared equals 15 squared plus 36 squared. So let's bust out La Calculadora. 1521 equals 15 squared is 225 plus 36 squared is 1296. And when I add these two numbers together, 1521 equals 1521. Oh my goodness. Because these two numbers equal each other, remember on the left side, originally we had the c squared, so this is actually c squared. And on the right side, we had a squared plus b squared. This is actually a squared plus b squared. Because they're equal to each other, we have proved that this is indeed a right triangle. Nice. Next up, we're going to be proving if the figure below is an acute triangle or not. So remember, let's just set up our Pythagorean situation here. C squared is, this time we don't know what it's going to be. C squared is something a squared plus b squared. We're trying to prove that this is an acute triangle. Well, C has to be the longest side, and then A and B really doesn't matter. A and B, I'll just put it like that. Then substitute your numbers in. C is 22 squared. Then I don't know what it's going to be. A is 17 squared plus 19 squared. Then again, get the calculator. 484 is something. And then 17 squared is 289 plus 19 squared is 361. So now 484 is something. 289 plus 361 is 650. Now, is 484 less than or greater than 650? It's less than. And if c squared is less than a squared plus b squared, then that means this is an acute triangle. Perfect. So now we've proved that this is an acute triangle. And lastly, we're going to have the prove that the figure below is an obtuse triangle. So once again, let's set up our converse of the Pythagorean theorem. So c squared is something a squared plus b squared. Which side is the longest here? Which one's the 23? That's the longest side. That's going to be C. And then it doesn't matter what A and B is. So A and B. So let's substitute our numbers in. 23. Okay, I don't know what. Okay. 23 squared. Bam. A squared is 14 squared plus B squared. That's 18 squared. All right, now the calculator. 23 squared is 529. Bam. 14 squared is 196. Plus 18 squared is 324. And then let's add these numbers together. Oh my gosh. Woo! This is 520. And now is 521 greater than or it's greater than. Woo, so this is going to fill in all. And look at that. C squared is greater than A squared plus B squared. Therefore, this is obtuse. Oh my goodness. Bam. There it is. So now try the problems that we didn't do together and, just follow the format that we did in the example problems and you'll be on your way to telling if a triangle is right, acute, or obtuse. But that's the end of this video, guys. So I'll see you in the next one. Peace.